Chapter. Washington Middle School. Hey, welcome back. Welcome first week of school after spring break, and our first week together with the coronavirus COVID-19 at home lessons. So it's gonna be fun. It's gonna be crazy. I'm sorry that we don't get to be together, but we're gonna make the most of it, and we are going to be respectful, responsible, and we are going to be safe as we stay at home. Hey, what kind of jokes are allowed during the coronavirus outbreak? What kind of jokes? Inside jokes. Oh, maybe that you don't get that. Okay, sorry. It may be loud in here. I've got my dogs running around, my family's running around. I know you guys have the same thing. You know, there's all kinds of stuff we have going on in our homes. It's hard to do school at home. This is going to be challenging. It's going to be different. It is not going to be normal, but we're going to make the most of it. Alright, our learning target today is that we can apply our understanding of balance to find the value of a variable. Alright, so what does that word balance mean? Okay, so the balance is, let's just draw a little scale here. We're going to have our little scale, and balance means that whatever is on this side is equal in value to whatever is on this side. That means that both sides are balanced. And what does the word variable mean? Now, variable is a letter, any letter. So A can be a variable. We can have Z is a variable. Any letter, as long as that letter represents a number. So A equals 7. Z equals 5. When we have an equal sign, we're in balance. So if I had A over here and 7 over here, and they were both equal to each other, then we would know that that is in balance. So what do you need when you are having school at home? Gotta have both those things, paper and a pencil. When we have school at home, gotta have them. So our entry task to get our minds going today is broken calculator. I want you to enter the number 21 into your calculator. Now, obviously, you're still on your paper, but you don't have the number 2. You also don't have the number 1. Someone has broken this calculator, so it is missing 4 buttons, the number 1, 2, and 4 and 5. So you are going to, on your paper, write as many ways as you can think of that you can come up with the number 21. Actually, at least 3 ways. I would like you to think of 3 ways to come up with the number 21. And when we get together on Tuesday at 10 o'clock, we're going to write these on a little whiteboard all together. Write your ways of coming up with the number 21. Now we're going to pause the video. You have time to do that, and then I'm going to start. Welcome back, Washington Middle School 6th graders. Let's start into our lesson now today. So again, we are going to use our understanding of balance to find the value of a variable. So let's go back to our understanding of balance. Go ahead and draw this with me. Go ahead and draw a scale. Draw that scale, and this side is in balance. The left side is in balance with the right side. Now if they were unbalanced, it would look like, you don't have to draw this, but it would look like this, right? It would look like that if it was unbalanced. Right, let's say that this side had 1 and this side had 1/2. So these are going to be unbalanced scales. But today, our scale today is balanced. That means the left side and the right side are equal. And the way we describe something as balanced in math, algebraic, we use the word or the equal symbol. This shows that this side is equal, is the same value. Left side is the same value as the right side. So now we have something on the left side that's equal to something on the right side. Now we don't know what the value of these two boxes is. They have question marks. And when we have a question mark, algebraically, we use a letter for that. So instead of a question mark, let's go ahead and change that question mark to a letter. I'm going to choose the letter X. X. So we have these unknown quantities, but we do have some known quantities. Let's call them kilograms. So on this side, we have 2 X's and 1, 2, 3, 4. And on this side, it equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how could we say that algebraically? How could we say that using our numbers? Well, on this side, that's easy. We've got 12. On the right side, we have 12. On the left side, how could we say that? Well, there's a couple ways we could say it. We first off have 4. So we know this number 4. That's pretty easy. And then we have 2 X's. So we could say X plus 4. Or a better way to say that in 6th grade, instead of saying X plus 4, we would say that 2 times X, or 2X plus 4 equals 12. So now we're showing algebraically what this balance, what this scale is showing. How can we find out the value of X now if we know that 2X plus 4 equals 12? What is the value of X? Let me think about that for a little bit. You can pause the video if you want to think about that. Well, the way that we can find that out, we can take away something from the left side and the same thing from the right side to find out what the value of X is. Well, if I take away something from the left side, I have to take away the exact same amount from the right side. So if I take away 1 from the left side, I have to take away exactly 1 from the right side in order to keep those scales balanced. If I take away 1 from the left side and I don't take away 1 from the right side, then this balance is going to move to the right. So if I take away 1, then I'm going to take away another 1. I have to take away the same amount from the right side. If I take away another 1 from the left side, I have to take away another 1 from the right side. And if I take away another 1 from the left side, I take away another 1 from the right side. So what I have done is I have now shown that these 2 X's is equal to 1, 2, 3, 4, 5, 6, 7, 8 on the right side. Now the way we can show that algebraically is we can subtract 4 from the left side, and we can subtract 4 from the right side. Well, if two x's, this positive 4 and the negative 4 cancel each other out. They're gone. The positive 4 and the negative 4 are 0. So we're just gonna cancel that out. So now we know that 2x equals, well, what is 12 minus 4? 12 minus 4 is 8. Well, if 2x is equals 8, then what does x equal? You can go write that down. Think about that. X equals what? Well, if 2x is equal 8, then 1x is equal to 4. Because 4 plus 4 equals 8. Or 4 times 2, 2 times 4 equals 8. Okay, another way to show balance besides using a scale is a tape diagram, right? The top tape is equal in value to the bottom tape. So, if I have a bottom tape that has the numbers 32, then whatever is on the top is going to equal 32. So, let's just say, we're going to put this, we're going to say 27 and n. 27 and n now equals 32. Now I would like you to pause this video and to write an algebraic problem that represents this tape diagram. Welcome back. All right, so you pause the video and we're back. 27 and n is the same as 32. How did you write that? Okay, so I'll bet you wrote it something like this. You wrote 32 equals n plus 27. Or 27 plus n equals 32. Either any way you write this, we're gonna say that's the same thing. Maybe you came up with a different way. Maybe you just came up with a subtraction problem. You can do all kinds of ways. Now, let's do another one. So we've got another problem now. We have 1, 2, 3, 4, 5, 6 p's. And that's going to be the same as 120. I would like you to write another algebraic problem that shows these two tape diagrams. You're going to have an equal sign because they're both equal to each other. Write that out algebraically. Down. You have 1, 2, 3, 4, 5. You have 6 p's. So the way we write that is 6 times p, 6p. And that is equal to 120. 120. Okay, so now we are going to find the value of p that makes this equation true. What value of p makes the equation true? Go ahead and pause the video and write that down. What value of p makes this equation 6p equals 120 true? Alright, so if you put p equals 20, then you are correct because 6 times 20 equals 120. Alright, so we've got another two tape diagrams. D and D equals is the same as 9. Go ahead and pause the video and write an equation that shows this problem. Okay, so we've got an equal sign because these two tapes are equal, and you have 2D equals to 9. All right, let's draw this another way. So we've done the scales, we've done the tape diagrams. Let's think about it as a hanger. So if I had a hanger, you just have this coming out of the sky. I've got a line over here, and I've got on this side of my hanger, I've got the number 27. And on the right side of the hanger, I have the variable b, and the number, I've got the number, a smaller box with 9 in it. Alright, go ahead and write an equation that shows what we have hanging here. How would you write that as an equation? Write that down, pause the video, and write that down on your paper. Welcome back, Washington 6th graders. What did you write? What did you write? Well, we have on the left side 27, and that is equal to what's on the right side. And what is on the right side? We have a b plus a 9, so a b plus 9. 9 plus b is the same thing as 27. Alright, so you're going to find the value of b that makes the equation true. Again, pause the video and write down on your paper what is the value of b that makes the equation true. What is the value of b that makes the equation true? Well, b equals 18, because 18 plus 9 equals 27. 1/5 and a z equals 3/5. Go ahead and write an equation that would show this problem. Now you've written that. We've got on the left side 1/5, and we are adding these together, plus z equals 3/5. Okay, 1/5 plus z equals 3/5. Alright, so you got another one. How would you write this out? What equation would you write to show that the left side is equal to the right side? Pause the video, write your equation. Alright, what equation would you write? We've got two k's here. So how do you write that algebraically? Well, you write 2k's is the same as 2 times k, so we write 2k. And these two things are equal, so we're going to say equals, and the right side is 18. So you've written 2k equals 18. Well, now, what is the value of k then? If 2k equals 18, then what does k equal? K equals what? K equals 9, that's right. K equals 9 because 2k equals 18. Then 2 times 9 equals 18. So k equals 9.